Okay, so now let's do an example that's more akin to the U sub U did in Calc 1, right? And see how they're related here. Okay, so we want to compute the integral, the double integral, over R of cosine y minus x over y plus x dA, where R is this trapezoidal region here, right? So before we even look at that trapezoid, look at what's inside this cosine. It's a mess. It's a complete and utter mess. So how could we make that look a little bit better? Well, if we say u is y minus x and v is y plus x, if we say that, then what happens? Well, then, if we do that, then cosine y minus x over y plus x, well, that's just now cosine of u over v. Now, it still has an over v in there, but it's okay. That looks already much better. But what do we do now? Well, we've made this change of variables for the function. What does that do to this region? Well, in order to find out what it does to the region, we need to know what does the region look like. So let's sketch that. So here's y and x, right? And then we have some points. 2, 1, 2, 1, 1, 2. Right. So we have some points here. 1, 0, 2, 0, 0, 2, and 0, 1. So that gives us this trapezoid here. Right? So this is the region R. Well, what are the boundaries of R? Well, this line here is just x equals 0. This one here is y equals 0. But what about these two? Well, you might recognize these as x plus y equals 2, and this one is x plus y equals 1. Right? Because they go from 0, 1 to 1, 0, and 0, 2 to 2, 0. Right? But notice something already. We already have that this is v. Right, so we get v equals 1, v equals 2. That's already kind of nice. Right? And also, think about integrating over this guy. It's going to split into two pieces. You'd have to break it there if you did y first, or if you did x first, you'd have to break it there. So regardless, you're going to have to break that guy into two pieces. Okay. Well, let's actually finish figuring out what this region turns into. And the way I usually like to do this is to make like a nice chart. So we start with our things in R, and we want to know what do they become when we go to S, right? So R, this is sort of the XY stuff. S is the UV stuff. Right? We're asking if we take the equations for R, so here we have x equals 0. Actually, let's start with the easier ones. X plus y equals 1. X plus y equals 2. Then we have x equals 0. Oops. Getting ahead of myself here. X equals 0. And y equals 0. We want to ask, what happens to each of these? So we already said this is v equals 1 and v equals 2. Now what about that? Well, if we plug in x equals 0 here, we get u equals y minus 0, v equals y plus 0. So these are both just equal to y. So we get u equals v. Let me circle the things they become, just so it's clear. Right? So now we got that. What about y equals 0? Well, we get to do the same thing. Plug y equals 0 in up here. U equals 0 minus x. So that's just minus x. V is 0 plus x. So that's just x. So then U equals negative V. And these are the 4 new pieces. So now, if we went over to the UV plane, we're going to see a picture like this. Here's V. Here's U. Let's say this is 2 and 1. Then V equals 1 and V equals 2 are these horizontal lines, right? So V equals 2, V equals 1, right? And then we have the diagonal and the anti-diagonal. Well, okay, that's still not too hard to do. Of 1 minus 1. So the diagonal goes like this. This is U equals V. And the anti-diagonal goes this way. U equals negative V. Or V equals negative U, whatever you need. And, whoa, what am I doing? All right, so this region in here, then, this is S. And this, notice, we actually don't have to split into 2 pieces, but we do have to integrate U first. Otherwise, it splits into 3, actually. So, okay, no big deal. Now notice, to change all of this stuff, I never had to solve for x and y in terms of u and v. In this problem, it's not so hard. Like y is u plus v over 2, x is v minus u over 2. It's pretty easy, but we don't have to do it because we've changed everything already to u's and v's. We just need the Jacobian. So we can do our trick from before. So let's find the Jacobian, sort of the backwards transformation from what we want. Right? So this is the determinant of minus 1, 1, 1, and 1. Remember here we're taking derivative of u with respect to x, u with respect to y, v with respect to x, and v with respect to y. Right? So this determinant is negative 1 minus 1, so negative 2. So that means the Jacobian that we want is 1 over negative 2. Right? Okay. So now let's actually get on with this integral here. So the integral over r of cosine y minus x over y plus x dA. This is going to be, well, let's set this stuff up first. Cosine u over v. Now remember, we have to do du first, but we also need to put in the Jacobian. So we have to take the absolute value of the Jacobian. Right? I'll just put the minus on top, right? And then du dv. Right? Now what are we integrating from? Well, u equals negative v to u equals v. Simple. Right? And then v goes from 1 to 2. Right? And then this shouldn't be a very difficult integral to compute. So 1 to 2, 1/2. If we integrate this with respect to u, we get v sine, not cosine. Oops. V sine u over v. This 1/2's here now. From minus v to v dv. Okay? So I'm going to take that 1/2 all the way out now. integral from 1 to 2 of v sine of v over v, so 1, minus v sine of negative v over v dv. Right? So you are, well, sorry, negative v over v is just negative 1. Let's go ahead and write that. All right, and remember, sine is odd, so I can pull that negative out. And so this is really just the integral from 1 to 2 of v times sine of 1 dv. Right? Because if I pull the minus out, I get 2v sine of 1, and the 2 and the 1/2 cancel. Right? So this is, let's do this, sine of 1 over 2 v squared from 1 to 2. So this is 3 sine 1 over 2. And that is all. Let me double check that answer here. Yep, that's all. Okay? So hopefully this made sense, and hopefully you see why this is a useful trick. You know, again, it didn't matter so much here because this was a pretty easy example in terms of solving for x and y. But I hope the message got across here. And I hope everything makes sense, and see you in the next video.